fractions. So again, thinking historically, fractions would not have been on that list in the book. Okay, it just listed our whole numbers. So it gave us the square root of 1, the square root of 2, the square root of 3, decimal forms. But it wouldn't have a fraction. That's ridiculous. There's infinitely many fractions. So when we have a square root of a fraction, we have to break it down so that we have some whole numbers here. Our first step in doing that is split it up so that we have the square root of the top over the square root of the bottom. Give the numerator and the denominator each their own square roots. So instead of square root of the whole fraction, make it square root of the top, square root of the bottom. Then simplify those individually. So square root of 3, well, it's not pretty, and nothing on that list goes into it, so it's just going to say square root of 3. What about square root of 4? 2. And this problem is finished, because we could look up what the square root of 3 is on that list, and then we could divide that by 2. So this problem is finished. Okay, so break it up into the square root of the top and the square root of the bottom, and then simplify or take those square roots individually. Square root of 1 over 5. First step, break it up into the square root of 1 over the square root of 5. They each get their own square root. What's the square root of 1? 1. What's the square root of 5? It's not pretty, so it's just going to say square root of 5. But this problem is not finished, because the square root of 5 is a really ugly decimal. So if we're thinking long division by hand, doing 1 divided by ugly decimal is not very easy to do. It's not easy to divide by a decimal. So what we need to do is now called fractionalizing the denominator. It means that in the end, we don't want any square roots on the bottom of the fraction. We're allowed to have square roots left on the top, but we are not allowed to have square roots left on the bottom. So the way that we're going to get rid of that square root on the bottom of the fraction is I'm going to multiply that square root of 5 by itself. Because, let's just worry about the bottom first, and then we'll worry about what happens on the top. If I multiply square root of 5 times square root of 5, what does that give me? Square root of 25. What is the square root of 25? 5. So that'll make the bottom of this fraction pretty. Now remember, we don't want to change the value of this number. So what can I multiply something by that won't change it? 1. Right? I can always multiply by 1, and that doesn't change it. So we're going to multiply by 1, but we're going to multiply by kind of an ugly form of the number 1. We're going to multiply by square root of 5 over 5. Because that's just 1. Anything divided by itself is 1, right? So when we choose what to multiply by, we're going to multiply by the square root that's on the bottom of the fraction, but we have to do that same thing on the top of the fraction too. So on the top of the fraction, 1 times square root of 5 is just square root of 5. So in the end, we have square root of 5 over 5. We can't reduce that at all. A lot of students would want to cancel this out and say that it just equals 1. But you can't reduce a number that's underneath the square root with a number that's not underneath the square root. Then you can reduce. And one can't cancel and reduce. So our final answer would be square root of 5 over 5. For our next example, let's do something kind of similar, but let's do square root of 3 over 5. Sorry. Oh, okay. First step, break it up. Square root of 3 and square root of 5 are not pretty, so there's nothing we can do with taking square roots there. We're not allowed to leave that square root on the bottom, so we're going to multiply by it. We are only concerned with fixing the bottom of the fraction. So on the top, we are also going to multiply by square root of 5, not square root of 3, because we want to be multiplying by 1, something over itself. On the top, what does that give me?
15.
Square root of 15. Since they're both under, we can multiply them together and keep it under. on the bottom, what does that give me? Square root of 25, which is 5. So we get square root of 15 over 5. And again, we cannot reduce those because one is under the root, one is not under a root, so they don't cancel each other. Square root of 3 over 32. Does that fraction reduce at all? Do 3 and 32 have anything in common?
No.
No. Okay. It would be a good idea to reduce fractions. It makes the number smaller, so it's easier to work with then. But it doesn't reduce, so we split it up. Square root of 3 is not a pretty number. Square root of 32 is not a pretty number, but 32 is kind of a big number. So what we want to do is simplify that square root of 32 like we did on our earlier questions. So what's a number that's a perfect square? So it was on that list of numbers that used to be on the screen on the right-hand side. What's a number that goes into 32? 4. 4 times 8. Okay, that would work, but there might be something better. Is there anything bigger that goes into 32? 16. So let's do 16 times 2. And the top is just square root of 3. So on the top I've got square root of 3. Square root of 2 is not pretty, so it stays. But I still have a problem because I still. So what do I multiply by? Multiply by square root of 2 over square root of 2. I do not multiply the 4 because the 4 isn't a problem. It's just that square root that's a problem. So I'm going to multiply by the square root of 2 over the square root of 2.
If you do the square root of 2 by the square root of 2, does it make it not 2? Like not square root of 2?
Right. Yep.
Okay.
Yep, that's why we multiply it by itself because that kind of cancels the square root then. What does that give us on the top? Square root of 6. Now on the bottom, the square root of 2 times square root of 2 gives us what?
4.
Square root of 4, which is 2. Anytime you multiply a square root by itself, it just gives you whatever was underneath. But I already had a 4 over there, so what do I have all together?
You have 2.
2 times 4, which is
6, 18. Wait, 8.
square root of 6 on the top and then just an 8 on the bottom.
So they times by each other. Oh. Right.
Yep. So anytime you multiply a square root by itself, it just gives you that number that was underneath. And then if there's anything else out there, we have to multiply by that. Questions? All right. I have one now for you to try then. You go ahead and try the square root of 28 over 3.
Is this the last one? Right now.
All right, does 28 over 3 reduce at all?
Yeah.
Anything go into 28 and 3? 28 reduce the fraction. So we'll split it, and 24. What's the square root of 4? 2. Square root of 7? It's just square root of 7. It's not pretty, and nothing else goes into 7. And the bottom square root of 3. This is not done yet because we're not allowed to leave square roots on the bottom. So what do I multiply by?
3.
Square root of 3 on the bottom. Also square root of 3 because we want to multiply. A square root times itself just gives us the number underneath. Can Can I reduce this at all? 21 and 3 kind of reduce, right? Can I reduce it?
No.
Why not?
One is a square root and one is a...
One's trapped under the root, the other one's free, and you can't reduce them if they're in different places. So that's done. As a side note, though, let's say our problem was something like 6 times the square root of 21 over 3. Can I reduce that? Yeah. There. The 6 and 3, since they're both outside, they can reduce each other and just give 2 roots of 21. Okay? So if two numbers are outside, you can reduce them together. But if one's out and one's in, they can't cancel each other. Questions? All right, your homework for tonight then is on page 288, numbers 1 through 15. Page 288, numbers 1 through 15 is your homework for tonight.